Last November, a gravitational wave detector in Louisiana picked up a signal. One of the objects that made it was lighter than our sun. And no star that has ever existed, can make a black hole that small. You're listening to Stardrift FM. Tonight, a signal from before the first stars ever formed. A naked-eye star that hid a companion for 50 years. A comet that stopped spinning and reversed. Moons that could harbor life without a sun. An AI that just found over 100 hidden worlds. And the storms that are still stealing Mars's water. Grab your coffee, let's get into it. On November 12, 2025, at 3:18 in the afternoon, Universal Time, the LIGO gravitational wave detector picked up signal S251112CM, a merger. Two objects spiraling into each other somewhere around 300 million light-years away. Routine, almost. LIGO has detected over 300 mergers since 2015. But this one was different. When the team calculated the masses, at least one of the objects weighed less than our sun. That should be impossible. Every black hole we've ever found formed from a dying star, and the lightest black hole stars can make are around 5 solar masses. Neutron stars, the densest known stellar objects, sit between 1.4 and 2.5. Below 1 solar mass, nothing in astrophysics can make that, unless it formed before the stars. Primordial black holes, theoretical objects proposed by Stephen Hawking in 1971, in the first fraction of a second after the Big Bang, before atoms, before light. The universe was so dense that random fluctuations in matter could collapse directly into black holes. No supernova needed, just raw density. University of Miami astrophysicist Nico Cappelluti published analysis of the signal this month in the Astrophysical Journal. His conclusion, the most plausible explanation, the only explanation that doesn't require new physics, is a primordial black hole. Now, this is not confirmed. The false alarm rate, meaning the odds that this signal is just noise, is roughly once every 4 to 6 years. LIGO physicist Christopher Berry put it directly, for an event this unusual, that's too high to claim a discovery. But if another subsolar signal shows up in the next observing run, starting September 2026, the case gets much stronger. And if primordial black holes exist in large enough numbers, they could explain dark matter. 85% of all matter in the universe, the invisible scaffolding that holds galaxies together. One signal. From before the stars, 55 years after Hawking first imagined it. If you go outside tonight and find the W of Cassiopeiae, 5 bright stars high in the northern sky, the star at the center of that W is Gamma Cassiopeiae, magnitude 2.15. You can see it from a city. Since 1976, that star has been a puzzle. It emits X-rays 40 times stronger than any similar massive star. At temperatures exceeding 100 million degrees, nobody could explain it. 2 hypotheses fought for decades. Maybe the star's own magnetic field was doing something exotic to its disk of gas. Or maybe something unseen was hiding next to it. This month, the team led by Eyal Nazé at the University of Liège published the answer in Astronomy and Astrophysics. They used XRISM, the Japanese X-ray telescope that launched in 2023, and its Resolve instrument, the most sensitive X-ray spectrometer ever put in orbit. Resolve can track tiny shifts in X-ray wavelengths, Doppler shifts, the same principle that makes an ambulance siren change pitch as it passes you. Nazé's team observed Gamma Cass 3 times, December 2024, February 2025, June 2025, covering the full 203-day binary orbit. The X-ray signal followed the motion of a companion, a magnetic white dwarf, not the B star itself. The white dwarf pulls in material from the larger star's gas disk. Its magnetic field funnels that material onto its poles. When it hits the surface, 100 million degrees. X-rays. A star you can see tonight with your own eyes. And for 50 years, nobody knew what was standing next to it. Here's something that's never been seen before. Comet 41, P/total Giacobini Crisac, about a kilometer across. It visits the inner solar system every 5.4 years, flung into its current orbit by Jupiter's gravity. In March 2017, the Discovery Channel telescope at Lowell Observatory measured its rotation period, about 20 hours. 2 months later, NASA's Swift Observatory measured it again, 46 to 60 hours. It had tripled. The comet was braking. Then Hubble looked in December. The period was down to 14 hours, faster than the original measurement. But spinning the other way, David Jewett at UCLA, the scientist who co-discovered the first Kuiper Belt object beyond Pluto, published the finding this week in the Astronomical Journal. The mechanism: gas jets. As a comet approaches the sun, ice sublimates and jets of gas stream off the surface. If those jets are unevenly distributed, they act like tiny thrusters. On a body this small, a kilometer wide, barely held together by its own gravity. That's enough to slow it, stop it, and push it the other way. Jewett's assessment of the comet's future is blunt. Quote, "I expect this nucleus will very quickly self-destruct. 41P has maybe 1,500 years left. Every orbit around the sun, the jets push harder. Eventually, the spin will tear it apart. We caught it in the act. There may be more planets without a star than planets with one. Free-floating planets, rogue planets, ejected from their home systems by gravitational encounters early in their history. Current estimates roughly 20 rogue planets for every star in the Milky Way. Trillions of them, drifting in the dark between the stars." A team from LMU Munich and the Max Planck Institute for Extraterrestrial Physics, David Dalpudden and Giulia Rossetti, asked a question: could moons orbiting these dark worlds sustain liquid water? The answer, published in the monthly notices of the Royal Astronomical Society: yes. For up to 4.3 billion years, almost as long as Earth has existed. The mechanism is two-part. First, tidal heating. As the moon orbits, especially in an eccentric orbit, the planet's gravity rhythmically stretches and compresses its interior. Friction generates heat. Same process that keeps Europa's ocean liquid and makes Io the most volcanic body in the solar system. Second, and this is the key finding, the atmosphere has to be hydrogen, not carbon dioxide. CO2 would freeze and collapse at the temperatures of interstellar space. Hydrogen stays gaseous. It traps heat through a process called collision-induced absorption, molecules briefly pairing and blocking infrared radiation from escaping, like a blanket that works in the cold of deep space. The paper also draws a parallel to early Earth, where hydrogen-enriched atmospheres from asteroid impacts may have created the conditions for the first prebiotic molecules. The tidal deformation even creates wet-dry cycles where water evaporates and condenses rhythmically. Exactly the kind of cycling that helps complex molecules form. No sun required. The Transiting Exoplanet Survey Satellite, TESS, has been staring at stars since 2018, looking for the tiny dip in brightness when a planet crosses in front of its star. 8 years of data, 2.26 million stars observed. A team at the University of Warwick built an AI pipeline called Raven, Ranking and Validation of Exoplanets, and turned it loose on TESS's first 4 years of full-frame images. The result, published this week in the monthly notices of the Royal Astronomical Society: 118 newly validated planets, 31 of them detected for the first time. Over 2,000 additional candidates, about 1,000 of those entirely new. What makes Raven different is that it handles the entire process, detection, classification, and statistical validation, in a single integrated pipeline. Most previous tools did one step at a time. Raven chains them and runs at 91% accuracy. The headline finding beyond the raw numbers: about 9 to 10% of Sun-like stars host at least one close-in planet. That's consistent with what the Kepler mission found a decade ago, but Raven's measurement has uncertainties up to 10 times smaller. And one more result. The team produced a first direct measurement of the Neptunian desert, a zone close to a star where Neptune-sized planets almost never exist because stellar radiation strips their atmospheres away. How empty is it? 0.08% of Sun-like stars. Almost nothing survives there. Mars used to have water, a lot of it. Enough for a global ocean somewhere between 100 and 1,500 meters deep. Most of it is gone. Some is locked in the crust, trapped in minerals through billions of years of chemical weathering. But a significant fraction was lost to space. Hydrogen atoms broken free from water molecules by ultraviolet light drifting upward and escaping the planet's weak gravity. The question has been, what drives that loss? Until now, the answer was global dust storms, planet-wide events that happen roughly once a decade. Big enough to heat the entire atmosphere and loft water vapor to altitudes where UV can break it apart. A study led by Adrián Brines at the Instituto de Astrofísica de Andalucía, published in Communications, Earth and Environment and covered widely this week, found that the answer is bigger than global storms. Even regional, localized dust storms do it. In August 2023, Martian year 37, a localized dust storm in the Syrtis Major region covered about 1.2 million square kilometers. Not global, regional. Using data from ESA's ExoMars orbiter, NASA's Mars Reconnaissance Orbiter, and MAVEN, Brines found that water vapor at 60 to 80 kilometers altitude spiked to 10 times normal. Hydrogen escape at the exobase increased 2.5 times. And here's the part that surprised everyone. This happened during northern summer. A season that was considered quiet for water loss. Previous models didn't predict it. Regional storms weren't supposed to matter. They mattered. That's Stardrift FM for March 29, 2026. Tonight, a signal that might be from the Big Bang itself, a star that hid a white dwarf for 50 years. A comet that stopped and spun backwards. Moons that could harbor life in the dark between the stars. An AI that found 100 new worlds hiding in the data. And the storms that are still, even now, stealing Mars's water. Thanks for tuning in. This is Stardrift FM.